John, you are looking at two places.
Yeah, one I've logged in for this thing as a buffer, as a backup.
But not in the same room, na?
No. It is, but.
Good afternoon, Shalini. Nice to meet you.
Good afternoon, sir. Good afternoon, everyone. Good afternoon, sir. Thank you so much. And I'm sorry that I'm not able to take it from the boardroom today. I just wanted to avoid meeting you all because I have slight cough and fever. So I thought I'll stay here and I'll take it from here today.
So we'll also be safe. You will also be safe. No problem.
Right. Thank you.
So can we start, sir?
Yeah, we should start.
So good morning, good afternoon, one and all. I'm John Hongre, Assistant Director, AICT. So before we officially start the webinar, let us give our obeisance and seek blessing from the goddess of knowledge. So I request the IT team to kindly play the Saraswati Vandana. Thank you.
या कुन्देन्दु तुषारहार धवला या शुभ्रवस्त्रावृता या वीणावरदण्डमण्डितकरा या श्वेतपद्मासना या ब्रह्माच्युतशङ्करप्रभृतिभिः देवैः सदा वन्दिता सा मां पातु सरस्वती भगवती निःशेषजाड्यापहा।
Thank you so much, Brismohanji. So I'll officially start the program. So what we at AICT and especially at Student Development Cell, we are trying to develop the students academically and otherwise as well, so that they have a 360-degree molding of their development in career and future life. So one such initiative that we have taken up is to arrange the market expert from the industry to speak to the students like we are doing right now. So this will go a long way to help the students in their opening up their perspective of the market as well. So today's topic is very interesting. It's the theme is circular economy, system building, and material flows. So basically, from my point of view, for the uninitiated people like me, as in a glance, I thought that this was something to do with the money market flows and something to do with some monetary and fiscal policy of the economy. But I checked up the net, and it was a very much more interesting topic. It's basically the term CE. In short, it's called CE. So it's circular economy. Basically, unlike in the linear economy, whereby we use the natural resources and throw and use policy, in circular economy, what they have done is basically the employees reuse, sharing, repairing, refurbishment, remanufacturing, and recycling to create a closed loop system. Thereby, it reduces the use of resource inputs and the creation of waste, pollution, carbon emissions. So basically, this is a need of the hour to mitigate our climate change phenomena, and this will help you and me, and basically, most importantly, help the planet system for our future generations. So to help talk about this, we have a terrific eminent panelist. We would officially be welcomed by Dr. Amit Datta. He is the Director of Student Development Cell, AICT. Then we'll have a brief address by our respected Honorable Professor Anil Saraswate. Then after that, we'll have the resource person itself, Ms. Shalini Goyal Bala, Managing Director, International Council for Circular Economy, New Delhi. Then we'll have the question and answers sessions, which will be taken up by the resource person itself, Ms. Shalini Goyal Bhala. Then after that, we'll have a small vote of thanks. So without much delay, I will ask Mr. Dr. Datta to kindly take the stage and welcome the participants and the.
Thank you, John. Thank you so much. Good afternoon, all. It's indeed my proud privilege to welcome personage Honorable Chairman AICT, Professor Anili Sasbuddhe sir. We are fortunate today we have eminent speaker Mrs. Shalini Goyal Bharla, the Managing Director at International Council for Circular Economy, a passionate academic leader in circular economy, and written India's first book on circular economy. Dear faculty members and students, for me, a circular economy is extended life is like an extended life cycle of product by sharing, leasing, reusing, and refurbishing. But in practice, it implies reducing waste to the minimum when a product reaches to the end of its life. So waste is the new raw material nowadays. And the business leaders and government around the world are increasingly looking beyond the linear intake, like take, make, dispose. It was an old model of growth, with a view of operating a strategic move towards an approach to fit for the long-term run. So the past research by the Alan MacArthur Foundation and others have demonstrated the potential of the circular economy. One that is restorative and regenerative by design and making effective use of materials and energy in the digitally enabled model of development. When design team gets together with other departments, use design thinking, they can conjure up resource efficient ways of delighting customers. So according to report published by Venture Capital Fund, India is expected to become the world's third largest economy by 2030, accounting for about 8.5% of global GDP. If the circular economy touches $4.5 trillion by 2030, then we are looking at a $45 billion opportunity, provided India captures just 1% of this market. So on behalf of AICT Student Development Cell, I once again welcome you all, and I inform you that the webinar will completely enlighten your pertainings to the circular economy. All the vital aspects regarding the circular economy will be conveyed to you all. You shall exit this webinar with a lot of takeaway. Our eminent speaker will answer most of the queries during the question and answer session. Thank you so much. Welcome once again. Thank you all.
Thank you, Datta sir. As you rightly said, waste is our new natural resources, and you have set the right tempo for the webinar. Now I call upon Honorable Chairman sir to kindly address the gathering, sir.
Thank you, Dr. John. Good afternoon to all of you, Dr. Amit Datta, and most importantly, the speaker of the day, about whom we have heard from both Dr. John and Dr. Datta, Shalini Goyal Bharla, who has been MD of International Council for Circular Economy. She has been one of the authors of the early books of circular economy in India, launched by the CEO of Niti Aayog. I remember that day when it was launched. And then she came to AICT, and we have had a MOOC course on our Swayam platform on the same subject of circular economy. And since this topic is so vast, I've been telling her that she must create more number of courses on this particular topic, dealing with plastics, dealing with the various automotive sector units, semiconductor. There are a huge number of applications of circular economy. And as in the beginning, Dr. John said that as soon as the word economy is heard, first time the mind goes to the economy. That means something to do with budget, something to do with the tax regime. This is what comes to our minds. It has linkage, no doubt, if those who are following circular economy, they must be given rebate in the budget for invigorating the philosophy of circular economy. That way, certainly it has connect with the economy of the country. But more importantly, the United Nations Sustainable Development Goals, 17 of those Sustainable Development Goals, all of them have or some connection, revolution around two aspects. One of them is economy naturally, therefore circular economy. If you want to really have sustainable world, circular economy is the answer. And then secondly, education sector, which is SDG 4. We need to create courses on circular economy. We need to create awareness amongst our students and faculty on this. And once our students and faculty learn the right practices, when they go into the industry, wherever they are employed, whatever job they do, they will follow the ethical principles of circular economy. But for a country like India, which is an ancient civilization, we all talk about Indian knowledge systems. I'm sure all of us are aware of a very typical culture of our Indians that we don't throw anything away. We have this principle of use, reuse, recycle embedded in our genes. And that is why in all our houses, if you look at some corner, there have been huge kind of accumulation of what we sometimes call raddi hai, ye hai, वो हिंदी में बोलते हैं या जुगाड़ है कई पुरानी पुरानी चीजों को हम एक जगह में रख देते हैं उसका उपयोग होता नहीं होता है फेंकने का दिल नहीं होता है यानी न फेंकना ये हमारा फिलॉसफी का एक अंग है और इसलिए हम बचपन में मुझे याद है जो सीनियर हमारे घर के फैमिली के लड़का लड़की होती थी उनके लिए एक नई किताब खरीदी जाती थी फिर उसके बाद उसका नेक्स्ट ईयर में दूसरा बच्चा वी यूज्ड टू हैव जॉइंट फैमिलीज सो द नेक्स्ट वन वुड बी नॉट रियल ब्रदर और सिस्टर बट मे बी ए कजन एंड द सेम बुक goes to that next person. Uske next year, maybe your real brother or sister will be there. She will also get the same book. And till it is torn to pieces. And we were all trained by our parents to make use of it very, very carefully so that at least 3 or 4 children will use the same textbook. And some of the teachers who are here, they must have all been exposed to the same cycle. And this is what we say either reuse or you say recycle, all of that. And recycle is whatever notebook you are using for writing purposes, some pages will be left out. Naturally, you don't use the whole 80-page notebook or 100-page notebook, 200-page notebook is what you used to use. And maybe in that particular year, 60 pages are used, the remaining 20 or 120 pages are blank. We don't want to throw them away. We used to pull out them and create another new, we called wahi, and then make use of it. I think that is the culture of use, reuse, recycle in our genes, in our psyche, in our DNA. And a little larger version of that is in the economy when we go to large-scale industry, maybe like Tata Motors or maybe Maruti Udyog or maybe big organizations like Infosys, how various products are available which are having a long life cycle. Dr. Datta was saying that we have to do it so efficiently that the life of the products themselves is elongated. Like our lifespan, which is officially called as 100 years. Human beings, Homo sapiens, are supposed to live 100 years. But some time ago, our life decreased to about 60, 70 years. By the time one retired in the service, we used to feel very, very weak and maybe hardly few years left. But today I see young people at the age of 80 and they are still active. They're still going for taking, even classes. And that means the longevity of the life of the people has increased because of research in medicine, research in various types of new ways of living that we have adopted. But at the same time, life of our automobiles, life of various machines that we use at home, right from washing machine to television, all of them have expanded There is a guarantee given by the compressor of the refrigerator for 10 years. So that means our product efficiency has increased, productivity has increased, and that will certainly also help in the circular economy. But more important, what we need to understand is end to end, right from starting with the raw material, which we use it as a resource, which is a natural resource available in our mother lap of the mother earth. From there, digging out, making use of it, transforming it into usable form, then assembling various types of items together in order to create a useful product, then using it for a long time, and then at the end of the life also, we do not consider anything as waste. And that's why the philosophy of waste to wealth, often the word waste to wealth is talked about. And that's why in our campuses, in our towns and cities, the water we get from the corporation or from the city water supply, after it is consumed, utilized, the water which is wasted through the bathroom and the toilets is not thrown away. How it can be recycled, you continue to use it for gardening purpose or flushing in the toilet. All of that is recycling. Same way, how water harvesting is done by collecting the water from the rainfall and it is cycled through the whole year so that we don't depend on external agencies for that power. In terms of electricity, not only grid power, but how do we generate power in our own houses, whether it is solar or wind or in any other form. I think all of this is going to reduce the carbon footprint, which is also an important aspect of sustainable development goals. Resources, we all know, are limited. And that's why the famous saying of Mahatma Gandhi was, we have enough for everyone, for our needs, but not enough for even one person's greed. And greed is very bad. If you have greedy phenomenon, then give anything, everything on the earth, you will still feel that it is not enough. And that's why, how do we become very concerned about it in terms of carbon footprint, in terms of resource being utilized correctly, efficient methods of production, waste to wealth, and end of life cycle. Don't throw away and then create nuisance in the nature, and which will create obstacle for our well-being in terms of hygiene, in terms of our environment being polluted, and therefore health will get deteriorated. So it has a lot of indirect issues as well. And that's why in the Western world, where countries used to have the culture of use and throw, one time use and throw is not in our psyche. We have use, reuse is the philosophy, and therefore even the discarded item, car, which has already utility of 20 years is over, how do we pull out some of the parts of that and make use of them elsewhere? कार का इंजन को पानी को पंप करने के लिए, खेती में लगाने के लिए, all of these are possibilities. We don't throw away. Same metal is recast and then make use of it. Same is the case with plastic. If it is not single-use plastic, we used it multiple times. And even single-use plastic and some of that which is degradable, non-degradable, we convert it into pellets and then make use of it in rapid prototyping machines. So in our life, nothing, no raw material or no product which has been used once, twice, thrice is useless. It is all useful, and we make use of it to create more wealth out of that. And that is what is circular economy. You go a full circle, come back to the same place. And I'm only an initiator of this debate, dialogue, or whatever. But I'm very happy that more than 150 odd students, attendees have joined, and they have been giving thumbs up. So the real thumbs up will come when Shalini Goel Bhalla will speak with her heart. She is after me for every now and then that why don't you arrange more webinars, more seminars? And because of our limitations, we are not able to do much more, but we want to see more and more such seminars to happen. And Datta and John team, they're a great team, and I'm sure they will arrange more such workshops for creating awareness. And not only Dr. Shalini Bhalla, but many others also will join the bandwagon in order to create the culture of the circular economy in our lives. Thank you very much. Namaskar.
Thank you, Chairman sir. From my exposure to Chairman's speeches for the past few months, he can speak on all topics very well. That means that he is well read. He is very well read and knowledgeable, in fact. So thank you so much for your guidance, leadership, and we'll always be looking forward to you for the inspiration, sir. Thank you so much, sir.
Yeah, thank you.
Now, I would like to call upon our resource person, Ms. Salini Goyal Bhala, who is the Managing Director, International Council for Circular Economy, New Delhi. But before that, I would like to ask Dr. Datta to introduce Ms. Salini Goyal, sir.
Yeah, thank you, John. I'm giving a very brief introduction about Ma'am Shalini Goyal Bhallaji. She is a postgraduate environmentalist, and Shalini is the author of India's first book of circular economy. She is presently managing director at International Council for Circular Economy, and she has represented India on multiple international platforms through her speeches and programs. She writes for many Indian as well as international magazines. Passionate about the circularity, she has been on circular economy committees of Niti Aayog and several other policy dialogues. Working on several international projects, she is a true woman leader, turns multiple hats. She has been a part of several FDPs and executive training programs at IIMs and IITs, and she is associated with the MSME Delhi government on their entrepreneurship mindset program. I once again welcome you, ma'am. Thank you.
So now I welcome the resource person, Ms. Salini Goyal Bhala, to take the stage. Thank you.
Thank you so much, Dr. Amit Dattaji, for inviting me here, Mr. John and his team, and the entire HTDC for arranging this webinar. I'm very thankful to the chairman, sir, for giving such a good introduction of circular economy, a subject which is not very well known to many people because it is discussed as the end of life waste management, which we are currently talking about. But Sir, being Sir and a learned person, has described circularity in the best possible manner. And I'm very thankful to all his support right from the beginning that he has given to us on all the initiative that the council and I have proposed to him. So once again, I would like to thank you all for being a part of this webinar today and to develop more understanding on circularity. My whole presentation today has been bifurcated into two different parts. The very first part is to understand what is circular economy and why do we need it. One term that is very closely associated with circular economy is linear economy. And this term of linear economy came, a lot of us are talking about circularity, but there is another associated term, which is linear economy, was also kind of started to discuss when we started to talk about circularity. So for the student fraternity who's joined us today, it is important to understand what is linear economy and why do we need to shift to a circular economy. And then I go towards talking about the system flows, the system thinking, and the material flows. The topic material flows is a very vast topic, as same is with the system thinking. But I think it is important for us to understand first why the concept and what is the importance of the concept. Sir, can I share my screen here?
Yes, you can.
Yes, you can.
Sure. Okay, can you see my presentation, sir?
Yes, you can. We can see your presentation.
Thank you, sir. So first of all, and I hope the slides are changing, right?
Yes, it is. It is.
Okay, thank you, sir. So what we need to understand is when we are talking about circularity, what is the need of circularizing our economies? We are talking about circularizing by why? What are the broad strategies of circular economy and how can we reach to a circular economy? What are governments doing to guide a transition to circular economy and their role? what are the possible policies to promote a transition towards circular economy? Because in any country, to make a move, to make a transition, it is important to have relevant policies in the place or the regulations that would help to strategize a country's transition towards circular economy. And lastly, the business models that will help in the transition towards circularity. So I begin with the very first thing is, why do we need to circularize our economies? This is a very simple graph which shows the international comparison by World Bank done in 2011. It's an old graph, but it is a simplistic view of the developing and the developed nations. So what we see here is that the countries on the bottom left are the developing or the least developed economies, and on the right are the most developed Western countries. If you look at them, we are talking about the real GDP per capita. You see this United States being at the top of the graph, has the highest real GDP per capita, whereas countries like Ethiopia, Nigeria, Bangladesh have very low GDP. So what is happening is, a lot of the countries which are least developed are emerging, like India, are looking at higher GDP, and everyone wants to increase their GDP to provide better standards of living to their people. Now, what happens if the GDP increases? There has been a direct relation between the GDP, the per capita, and the resource consumption. And what we see is that there is a report which was released by Decoupling Natural Resources, again by UNEP in 2011, which shows that as the GDP increases, the resource consumption also increases. So again, if you look at the graph, it's a straight line graph. It's a straight line graph. It shows that India, China, the emerging economies have lesser resource consumption, whereas countries like US, Qatar, UAE, which are the most developed, have very high resource consumption. So there is a direct correlation between them. And if we look at the world population, we see that though the exact number, the population data, the numbers are actual numbers, the rate of population growth has decreased, whereas the actual number is increasing. And this will increase till 2100. This also means that there will be, with the increase in the population number, there will be an increase in the resource consumption. So here is the resource consumption graph, which shows that as the population is going to increase till 2100, the resource utilization and consumption is also going to increase. And this will lead to a massive consumption at the global level of all the resources. So why we infer that there will be an increased resource consumption? Is that a problem? Or why do we call it a problem? Now, this leads to an understanding that the way we are consuming our resources, it shows that it leads to a kind of inference that we have perceived that our resources are infinite. And the way we are consuming them, producing them, and disposing them, we will keep extracting the resources as long as we are living, or maybe even our future generations are living. So we are considering that the earth has an infinite regenerative capacity, whereas that is not the case. We have already seen through multiple reports and researches that we are consuming 1.7 earth that's an earth overshoot day as well, as we call it, and there are different terminologies that have come out, which shows that the consumption patterns are in fact way beyond the regenerative capacity of the earth. So now that we know that we do not have infinite regenerative capacity, it's leading to tremendous planetary boundaries being, we are actually crossing our planetary boundaries. It's leading to the climate change. You look at the land is being degraded. We are looking at oceans, the marine life. We are looking at the climate change. All these things are the impact of the planetary boundaries being crossed, and we are increasing that with every passing day. As we are speaking, we see countries like Netherlands and UK are actually issuing high alerts for their citizens because the temperatures that they are seeing are irreversible and are very impactful. Only today I was in my meeting with someone from Netherlands, and they were showing to me how the increase in 3 to 4 degrees Celsius in Netherlands has led the land to crack. The systems have fallen because they are not ready for such a kind of high temperature. People are sulking because they're not used to these kind of heat. So these are the kind of climate change, and we are seeing how half the Indian cities are flooded with water, whereas the other half is dry and is not even reaching the normal rainfall. Now, this is all because of the climate change, the changing patterns of climate, which is impacting all other systems. So now why do we need to, and how can we decouple this? So while the population is going to increase, the consumption patterns are still going to increase. What is the way to decouple it? And here is a simple graph that will help you understand how can we decouple the resource consumption from the economic development. So what I see is, if you look at this graph, there are three kind of economies that we're talking about. One is the economy which is least developed economy, then there are emerging economies, and then there are developed nations. We need to do a relative decoupling or an absolute decoupling depending upon the type of economy. And from the next slide, where we have these three economies, you'll be able to understand what kind of graph do we see for these three kind of economies. For the least development economies, we need to strongly decouple between the two. We need to increase economic activity because there is still a lot of GDP that needs to be increased. So in the least developed economies, we need to increase the economic activity while the resource use has also to be increased. So this is it is a mild decoupling that is required. In case of developing countries, there is an absolute decoupling that is required because they have very high GDP and high resource usage. What we need to do is the economic activity needs to remain the same, whereas there needs to be a huge reduction in the resource consumption. And that's why we call this economy to have a strong absolute decoupling. Whereas if we talk about the emerging economies, they need to increase the economic activity to increase the GDP. But at the same time, there needs to be a slight decrease in the resource consumption, and this is called the mild absolute decoupling. So depending upon the type of economies, the path towards the decoupling has to be different and is to be based on the type of economy and its resource usage. We cannot have one shoe fit all kind of a strategy. When we see most of the Western nations, they want us to also adapt to the ways or adapt to the timelines that they set, which is not happening because the way we are developing and the way that the developing economies are choosing and the resource consumption is very different. Also, the waste generation in that case is very different from the developed economies. So every single economy, these three graphs shows the three different ways different economies can take. So what are the strategies to reach to a circular economy? When we talk about circular economy, one thing that we come across is a circle, and I think like everyone considers what is a circular economy is to start with a circle, and everything comes back into it. And most of the times, what we consider is using the resources again and again, and once it comes to the end of its life cycle, reusing the resources. While we talk about this is a very good example and is a very good explanation of circular economy. But I would also like to talk about circularity from a very different perspective. If you look at the upper diagram, it is a straight arrow which shows that the resources on the left-hand side of the arrow represent the resources which are extracted. The green circle represents the economy. So the resources enter the economy, they're used, and they are disposed, and they goes out from the economy, and that is what our linear economy is. So the take, make, dispose is represented by the upper diagram, the top left diagram. Whereas if you look at the bottom right diagram, it shows that all the resources are within the economy, so within the green circle, and this shows that these resources are reused again and again, and they never leave the economy. That means we are not disposing anything. We are removing the culture of waste. Like Sir said, waste to wealth is exactly what we are talking about. But at the same time, another very important perspective to look at this diagram is that there is nothing entering in the economy as well. And by that, we mean that the resources that once extracted are there in the loop, as and hence there is no need to extract more resources from the Mother Earth. A very common, popular, and much talked about example is the semiconductors today. Also, the lithium ion battery. We know that these all are rare earth metals, very present in very limited areas on the earth, and all the countries who possess them have increased the rate. The supply chains have been impacted, and there has been a lot of disruption in the entire supply chain, and the products that uses them, the rates have shot because of the supply demand gap. uh, what is the alternate? The alternate, every single government that's looking at it is to use the waste from the discarded devices. So be it the mobile phones, be it cars, be it any other electronic equipment which is using that. We are talking about scrappage policy in India. We are talking about electronic waste EPR has been introduced as a policy in India. Again, the reason is so that all the waste that goes out of the economy is brought back into the economy through extraction. And we may not need, if that is the case, we may not need to extract more resources. One very good example that comes to my mind is also Singapore. Singapore is a landlocked country, as we all know. It does not have water resources, ample water resources to feed its population. So one practice that Singapore started long back was reusing its water. And today, because they use every single drop of water properly, they are self-sufficient. And like Sir also said, the gray water is recycled. Singapore has a technology which can recycle gray water, even black water, and change it into a potable water, which is very rare and which is a unique example in the in globally. And I have witnessed this, that their black water could be converted into potable water through the technologies, and this is what made Singapore independent and self-sufficient in its water shortage. Similar kind of models are emerging in multiple other areas, other sectors, where the resources are reused and kept within the economy. While we talk about the previous diagram, we also must look at this diagram, and there is a slight change. I would request the audience if someone could explain to me what is the difference between the previous diagram and this diagram. Anyone?
Whoever would like to answer this can raise the hand, and we can unmute you. Harshal, Mr. Harshal. Kavita Khatri. Yeah, you can speak now. Kavita Khatri.
Recycle our resources, but in this circle we can recycle our resources that are very few for us.
Right. Anyone else who would like to? Okay. So I would, yes, ma'am, you're right. Recycle our resources, which are few, but at the same time, this thinner circle also shows, Kavita, that uh, we actually extract less resources, we reduce the consumption, and we depend on lesser resources. So one of the things that I'm trying to say here is that while the population is increasing, there is a way to reduce our consumption. So we consume less so that there is lesser resource consumption, and there are lesser resources to be kind of recycled. And it is, though it sounds easy, it is difficult to achieve, but it's not impossible at the same time. So we are talking about lesser consumption, lesser waste, and more kind of reusing of resources. So these are the strategies, broad strategies of the circular economy. In a circular economy, there is a very famous diagram which is called the butterfly diagram, which was introduced by Ellen MacArthur Foundation. But these things have been taught since 1962 when Walter Stoll from Germany, he started talking about loop-based approaches. What we say is we are actually rediscussing the previous two diagrams where we are saying that there should be a loop, there should be the material should be brought back into the into the economy, either by the way of reusing it, refurbishing it, repurposing it, or remanufacturing it. Recycling is also one of the ways to put the resources back into its place, but we must understand that recycling is not the best value proposition that a circular economy promises. This will be more clear from the next diagram that I'm going to show to you. Before that, I would like to discuss the narrow concept that we are talking about. And the narrow concept, as the diagram said, showed, was that if we kind of make fewer products and we make more efficient products in terms of modular approach, so and extend the life of a product by either repairing or maintenance, then there will be lesser resources flowing in the economy. And that is how these are the broad strategies that will help in narrowing down the entire loop. So if I were to give an example, the best example is of a mobile phone. Today, if you look at it, the mobile phones, they come as a single device where everything is integrated within the phone. You cannot open the phone and change a module or a part of it. So there is a strategy which is called material and component strategy. The idea is that the mobile phone be made into several components and several modules. So if one module goes off, we are able to replace that module with another one. The best example is the Nokia phone. When the mobile phones were first came into our hands, Nokia mobile phone had separate battery. So if the battery would not work, we would change the battery, not the entire phone. So this is one way of extending the life cycle of the mobile phone. And similarly today, if you look at several strategies by the businesses, one strategy is called the law of obsolescence, where companies are or businesses are intentionally incorporating obsolescence in in their business models, be it relative obsolescence or absolute obsolescence. It could be technical, it could be multiple kind of obsolescence, and I'll be very happy to share an article that I wrote on obsolescence, where there are different strategies that have been implemented by the businesses to reduce the life and increase the profit margins by increasing the consumption of the products. Whereas what we need to do is exactly opposite. We need to reduce the consumption, make the products more efficient, introduce modularity, and also introduce systems where people can easily repair and maintain their devices. So this is a narrow flow that we need to introduce. This is the diagram that I was talking to you about. This is the famous butterfly diagram. On the left-hand side, we see the biological products, the green ones, and on the right-hand side, we see the blue ones, which is the technical cycle. So in circularity, we differentiate the products as the products which are technical and the products that are biological. All the biological products could be actually used as biogas for restoration, for compost, for farming collections and could be also fed into the feedstock. Whereas all the technical materials, they could be actually used for elongating the life cycle either through maintenance, reuse, redistribute, refurbish, remanufacture, or recycle. The longer the loop and farther the loop, the value proposition reduces. So if we look at the cascades, if we look at loops, maintenance is the most valuable proposition. And recycle, as you can see, is the biggest and the outermost loop. It is the least value proposition in a circular economy. Also, you will notice that energy recovery and landfill is the last option, and we are not looking at energy recovery and landfill as the best option in the circular economy. Now we come to the material flow and what is a material flow. If we consider a system, a kind of in any production company, I'm taking an example of a company to begin with, and we'll look at it from the other perspective later. The material flow is the most important factor in a production company because products are created from materials. A factory, only if the products are sold can factory cover its costs. Therefore, it is imperative to move the material between appropriate steps of the value chain directly and as quickly as possible. And that is why we see companies, they quickly work on to they have assembly lines, and through these fast moving assembly lines, they would assemble and push the products in the market. There is a sequence of the processes from the extraction of raw material to processing and to the delivery. So we see there are online deliveries. There are e-commerce services that are promising you 10 minutes or less than 10 minutes delivery. Again, that is all a part of the material flow, which is all leading to faster consumption and more consumption. So if I were to talk about the material flows are of two types: the external material flow and the internal material flows. So if we talk about the external material flow, it is usually performed by the logistics service providers in conjunction with the other customer orders. The in-house material flows usually fall into the company's own responsibility. I will discuss about the in-house a little later, but external material flows is the entire supply chain, entire logistics and service providers who deal with the material. So it could be from the extraction, then the production cycles. We understand today that the supply chains are global. The material is sometimes, if you look at the entire supply chain, you will understand that the materials are extracted in one continent. They are then sent to another continent for production and are then manufactured somewhere else and ultimately sold in some other continent. So one of the research studies also suggested that a pair of shoe that we wear, I won't name the company, travels 5 continents in the entire logistics, in the entire lifespan. So you can understand, while we talk about maybe the production as one of the cycles which is leading to the environment, we are not considering the logistics and the supply chains that have been built by the company into the entire system. So that is one thing that we need to look into. The in-house material flows start with the delivery of the raw material parts and also the subparts of the incoming goods warehouses, and ends into outgoing goods department with the delivery of finished and also semi-finished goods. Now here we look at the material that is reaching within the factory and is then the finished product leaving the factory. When we talk about this, this is because this is within the production houses. We will get a lot of data. We will get a lot of understanding of how the material flows within the organization. This is easy to handle as compared to the external material flows, which is rather very difficult to handle. The objective of the entire exercise is to minimize the workload associated with the material flow. And as a result, automatic transport systems are used in most of the production lines. Since there are normally no value creation in the product through the transport, despite all kind of optimizations that have been done globally, the material flows should always be reduced to the transport processes that are absolutely necessary. This is an idealistic kind of a scenario where we say that it should be reduced, but how and how the chains are looking at it. Are they ready to decentralize? Are they ready to kind of localize? Are the very big questions of the which represents the kind of challenge to the material flows. Is the material flow important? Yes. We are talking about frugal innovation. We are talking about lean manufacturing. And so there are 7 types of waste that we talk about, and we acronym them as TIMPOD. It's transport, it's inventory, it's motion, waiting, overproduction, over engineering, and drops, defects. Pre-consumer waste and post-consumer waste are 2 kind of wastes which are usually ignored from the material flow. That is why overproduction as well as over-engineering are the 2 kind of waste streams and the material flows which we are mentioning here. They play an extremely important role when we talk about the entire material flow system. So there are 2 types of waste, as we call it, the transport and motion. Already deep into a large degree on the layout design, the type of waste transportation refers directly to the material flow. Transports are definitely necessary because several processes in a factory are performed in different workplaces. Whether or not they are really necessary in the current scope depends upon the design of the layout. Now, that totally depends upon the production houses. Material flows often run back and forth through the production, and the part travel countless kilometers from the beginning of the processing to the finished product. Significant optimization of the material flows can be achieved by redesigning of the layout, and the transport efforts could be reduced by approximately 10 to 30%. In other words, not waste or necessity is the question, but how can we design the material flow to avoid waste is the question. So here we are talking about redesigning the material flow to avoid waste. This is one scenario which I was trying to discuss about a company. But has the companies thought of, if you look at the previous 2 slides, you would see that the companies are talking about the waste till the consumption happens. But is there a way of tracking the products after they have been used? The problem is that the industry is not looking at it or was not looking at it till recently. So we don't know what was happening to the products after they were being used. Also, if we look at all the previous slides, you would understand that while we talk about the material flows within a company, which is very easy to kind of look at, what happens when we are talking about material flows at a bigger, in a bigger system? Let's say a industrial cluster. So let's say if we are in Delhi, let's say the Delhi Industrial Corporation. So how do we look at the Delhi Industrial Hub? Or as a city. So if you are in Mumbai, how material flows within the city. Or as a state, let's say Maharashtra as an overall state, or let's say even at a bigger scale is India as a country. How much material flow is happening within the country is something that we need to understand. As a student, if I were to ask you to kind of map the materials within your family, then your neighborhood, then your city, maybe these 3 to talk with, will you be able to map that? So it is important to understand what materials are incoming and what materials are outgoing. A lot of times when I discuss with people, uh, only a few days back, this is a very interesting discussion that was happening. I was talking to a scientist in Netherlands, and he came out with a very sophisticated but very intriguing idea of creating carbon dioxide emissions while he was using internet. So he studied and he was trying to find out how much carbon dioxide emissions happen when you're using per MB of data. And to our astonishment, it was huge. And he wanted to create and show to people that using internet is also leading to carbon emissions. And when we were discussing this with many people, environmentalists also, which included environmentalists, it came as a shock that people would not really associate using technology or using IT or using data for that sake with carbon dioxide emissions. So every MB that you consume is also leading to carbon dioxide emissions, and that is an outflow of the material. And somewhere there is a lot of energy that goes into it. There is a lot of material that goes into providing that per MB that we are consuming. So these kind of material flows people are not aware of, and we need to understand that every single thing that we are consuming has an associated material flow. So as a student, I would definitely like to, while we are talking about the projects, I would like students to work on the material flows, starting from a very smaller units to going to the bigger units for that sake. What we need to consider are the total inputs and the overall outcomes. And as I said, overall outcomes also include any type of carbon dioxide emissions or greenhouse gas emissions that happen has to be a part of it. When I talk about this material flows, it is pertinent to mention about the report that Eurostat releases on Europe. And this is EU report. This is very, very popular and very well received report across the world, which talks about the overall material flows. So we are now looking at material flows in EU. We are talking about the entire European Union in 2020, and the units are in billion tons per year. So if you look at this diagram, you will realize that the materials extracted by EU is 5.2 billion tons per year, and whereas they are importing 1.5 billion tons. This kind of material, 5.2 plus 1.5, enters the European Union. It's used by the society and the economy. And out of this, only 0.8 billion tons per year is recycled, 0.7 is exported. It leads to 2.5 billion tons per year of emissions, whereas 0.7%, 0.7 billion tons is landfill. So it's a it's a diagram at a very big scale, whereas we'll discuss this at length in the coming slides, but this is the flow of material in European Union. So the same thing has been now kind of bifurcated into import and exports, which are the flow of material, products, and waste between different economies. Now, it is important to also understand how the waste is flowing. The closed loop represent the residuals that are not discarded into the environment, but are reused in the economy, either to produce secondary raw material or for other purposes, preventing further extraction of natural resources. The incineration of waste to produce energy is not the part of loop, but has its own flow and eventually produces air emission. So you can very clearly see that incineration is not included into a circular loop. We are looking at the loop, we are looking how the resources, how the materials are flowing. This diagram is called a Sankey diagram, which represents the material flows, materials extracted to make products or to be used as a source of energy. So it includes fossil fuels as well. Products flowing in and out of our society. And third is the material and products which are discarded into the environment as residuals, like landfills, air emissions, which are recovered and fed back into the economy. And this latter part closes the loop in the circular economy. So only the latter part, which is feeding back into the economy, will lead to circular economy. Rest all is still kind of a unidirectional flow. Infrastructure such as buildings, roads, machineries are used over a longer period of time, during which they mount up in our societies until they are eventually dismantled and taken out of use. So there is a longer life cycle, but they stay in the economy for a longer time. The Eurostat Sankey diagram of material flows shows the amount of material extracted, imported, recycled, or disposed, as well as its related emissions. In the figure 1.1 that we had seen, flow the material economy in 2020 in EU. So there are some very important information that we see in the diagram. First, The flow runs from left to right. Second is the width of the bands, which is directly proportional to the quantity of the flow, which is measured in billions of tons. Third is the material shown in the diagram are the biomass, which is used for the food and fodder, clothing, the wool and cotton, timber as wood, metal and non-metals, the minerals, fossil fuel carriers such as the crude oil, use of produced fossil fuels or materials such as plastics. It does not include water. It does not include renewable energy sources, and it does not involve the material flows. It does not include the material flows such as electricity from the photovoltaic panel or the wind farm. The fourth important point is that the fossil fuel carriers and the biomass produce air emissions as a result of being burnt to release energy. So if we look at this diagram and we look at now each and every part separately, we see that this diagram is built on a series of nodes. Each node is representing an event or process, example, like the imports and the material inputs, connection between the nodes which represent the material flows. So if you look at this, there are imports and there are natural resources that are extracted. A wider natural resources, the band shows that there are huge, the quantity is more, and a thinner import shows that the quantity is lesser. Is the direct material input. That's the first node. So this is what we were talking about, the direct material input and the inputs. Then comes to the second node, which is the processed material. So how much material is processed, which will also include the recycled and the backfeeding material. So the processed material and how this processed material is finally, either it's leading to the total emissions, is it going to the waste, is it being accumulated as material, or is it being used for a longer duration in the economy, are the different nodes of this Sankey diagram at different levels. So now we see that there are materials which have a shorter and a longer life cycle. So there are some products like food, which is a single-use item. Then there is paper, which is used for less than a year. Then there are long products like the buildings that we were talking about, furniture that we are talking about, and the assets, even longer, the machinery and the buildings. On the right-hand side of the Sankey diagram shows the output from the economy. So the export of products in their simple mass weight, emissions, and dissipated flows, be it in terms of unavoidable consequences of the product use, material fertilizers, or any other thing. The several outputs come from the waste treatment. So incineration is one of them. Waste is incinerated to extract energy, as we know. However, this also produces air emission, and incineration is thus a huge debate. Is that for it being circular or the non-circular? Most of the circular economists, if you talk to them, find incineration as not a sustainable model, whereas many economies have adopted waste to energy plants, thus incineration as a part of it, which they call a circular alternate. Waste landfill is the disposal of waste, including landfill and other operations. Recovery operations involving waste material being reprocessed into products, materials, or substances to be reused either for their original purpose or any other purpose. It includes recycling and backfilling operations. So here we are talking about the exports, dissipated flows, emission to air, emission to even water for that sake, the incineration and waste treatment that is leading to the landfill. So these are the external flows, the outside flows. Further, the Sankey diagram also breaks down the resources. So if you look at the materials, they have even broken down it further in different colors. So different colors in this diagram are showing you the different categories, be it the biomass, be it the ores, metallic and non-metallic, be it the fossil fuels. So these are different, including plastics, are the material flows in the EU, which is a further kind of breakdown of the similar diagram. And as we talk about this diagram, there is no single summary indicator for circularity of our economies at a macroeconomic level, whereas Eurostat has developed a new indicator for EU monitoring a framework for the circular economy. Most of the economies in EU, the countries in EU have come up with a framework on circular economy. They have strategies in place or plans in place to guide circularity for their nation. And this new indicator, which has been launched by Eurostat, is called the Circular Material Use Rate, referred to as the circularity rate, and it measures the contribution of recycled materials toward the overall use of material. So basically, they have correlated it to the recycled material. The circularity rate is the share of material resources used in EU, which came from recycled materials. I'm sorry. Thus saving primary raw material from being extracted. A higher circularity rate means that more secondary material replace primary raw material. So the idea is to use more secondary resources, thus reducing the environmental impact on extracting the primary resources. In 2020, the EU circularity rate was 12.8%, slightly up as compared to the previous one, and 4.5% points up from 2004, the first year when they started collecting the data on recycling. Also, the circularity rate is lower than other indicators of circularity, such as recycling rate. So recycling is higher, which is around 55% in EU. It is even higher in India. But circularity is obviously much lesser than that. This is because some type of material cannot be recycled, like the fossil fuels, which end up the biomass, the food and fodder that is single use, and also leads to emissions and the end of life cycle. This can be seen by comparing the size of nodes at the beginning and the end of the green feedback loop in figure 1 that we were discussing. A higher circularity rate can be achieved in more ways than higher recycling rates and require deeper transformation within our societies, like replacing the fossil fuels, using of more renewable energy, hydropower, waves and oceans, wind, solar photovoltaic cells, solar thermal, geothermal, by using more efficient production technologies or extending the lifespan of products. Now, this table shows the circularity rate for the EU and its member state with a comparison of 10 years from 2010 to 2020. If we take the example of Sweden, we see that the total circularity rate was 7.2 in 2010, and it has reduced to 7.1, a minimal reduction in the use. A lot of it can be explained by the COVID scenario, where the systems were closed. But if you look at that, again, if we look at, let's say, France, it was 17.5%, and which has now come to 22.2. So the circularity rate is increasing in certain countries, but decreasing in the others. With this, what is a system thinking? System thinking is the ability to understand how the parts of a system interact to produce the behavior of a whole. Donella Meadows of Ellen MacArthur describes it as a way of thinking that gives us the new gives us the freedom to identify root causes of the problems and see new opportunities. At the opposite end of the spectrum, if we apply reductionist, that is linear cause and effect, thinking to complex problems, we will likely arrive at solutions that lead to unintended consequences. So let's see what is system thinking. There is a small video. I hope I can play it. Yeah.
It's not playing, ma'am.
Is it not showing, sir?
No, it's not playing. It's shown, but you need to click on the playing button. Yes, this red one.
I'll restart. Is it okay, sir?
No, it's not playing.
Is it
Can
playing
you
at your
see?
end?
It is, sir. It is. Can you see my other screen? Maybe I need to reshare my screen. Hold on, just. I'll just reshare. I need to share the other screen, I think. Can you see it now, sir?
Yes.
Thank you.
You have to unmute it. Audio is not coming.
Can you not hear it, sir?
No, voice is not.
Okay, can you read the captions?
Captions are readable.
Okay, let's read that and see. So it's a very interesting video that I find, and they say that unless we know the problem, we need to understand the entire system before we get into providing a solution. Otherwise, the solution itself could be a problem. Hello. जी सर Are we out of the meeting? I can't see the.
No, you are in. Can you hear me? Miss Shalini?
Yes, sir, I can hear you.
You can start your presentation.
Yeah, I'm just sharing it. So what does this have to do with economy? Firstly, it is very important to understand some of the relationships that shape our economy. At the most basic level, an economy is a name we give to the processes, society, making use of the natural resources to create products and services that people need or want, like the homes and the food. Viewed in this way, if we look at the economy, our economy, society, and environment are three interdependent systems and are equally important. This is a simple yet profound reality that begins our understanding of the system. And if you look at this example of the cats and starting from malaria, it is the entire system thinking that needs to be developed around it. So what is the role of system thinking from this example? It plays a dual role in circular economy. It has an enabling tool that can help us identify root causes and implement better solutions, and it provides the lens or frame for our conceptual understanding. In circularity, we look at it from as a shift to a system where we are totally designing out waste. There is nothing called waste, right from the beginning of the cycle to the end of life cycle. The focus shifts from the end of life cycle to the design process. We rely more on regenerative natural systems, so lesser dependence on the fossil fuels and more use of the regenerative systems. And once the products are made, we look at extending their life cycle through elongated usage, and that's called the life cycle extension, the three most important strategies for it. One very good thought that we think about is what is the overlap between the story and the story of our current linear economy? Would system thinking would have helped them in any way? So if there had been a system thinking, would the current linear economy model stay? Are we talking about the flow of wealth? Are we talking about the wealth of flows? I think it is really good, and I have had several discussions. I'm fortunate to have these discussions with Ken Webster, who was then the head of innovation at Ellen MacArthur Foundation, and we have discussed these issues multiple times as to what are the new models which are based on our current knowledge of the nature-based solutions or the living systems, as we call them. There is another video, but I think playing the video is a little hack up. I'll play it at the end of it. The second last slide, which talks about the difference between the design thinking and the system thinking. The design thinking is a bottom-up approach where we think about the technology, we think about the business viability, and we think about selling proposition, the desirability for the consumer. Whereas the system thinking is a top-down approach where we think about the businesses, the technology, the economy, people, social, and then we kind of take a decision on to whether the decision is what is the best suited model for a particular thing. That's system thinking. So the choice is ours. Do we want system thinking, or we still want to operate in silos? I think that is the importance of collaboration. Both design thinking and system thinking have their own role to play and has to be coexisted for our sake. With this, I would also like to share with the student fraternity present here today that the International Council for Circular Economy works on several projects, and we provide internship opportunities to the students. If you are willing to work on projects that are related to these topics, you are most welcome to do an internship with the council. As Sir discussed, there is a SWAYAM course which is available. There are 4 courses which are available on our website, and there is much more for colleges. The The 32-hour 4-point credit open elective course has been introduced by AICTE in the model curriculum. In case you want us to help you deliver that course in your college, we'll be more than happy to associate with you. That's all from my side, and I'm open to the questions now.
Thank you, Ms. Shalini. I think now we are open to questions. Whoever want to ask a question can raise their hand and we'll unmute. And then whoever is on the YouTube, you can write the questions on the YouTube comments and then we can pass it on to Ms. Shalini. So we have Kavita Khatri for the first question.
No, sir, no
Please.
question.
Yeah. Yeah, Kavita, go on.
No, sir, no question.
Professor P.K. Tandon?
Yeah.
Go on.
Am I audible?
Yes, you are.
Okay, Professor. Thank you for the nice talk. I had been in Delhi College of Engineering for 35 years, and now I am founder director of Bhagwan Parshuram Institute of Technology. You see, I just want to say on the personal basis how the recycling or the use of the used item can be done. You see, I have and everybody has, so many adapters. When we buy different phones, they have different adapters. So I had 10 to 20 different adapters for charging. So each of them was generating 5 volts. So what I did was I placed them in series through a rotating switch, and therefore I was able to create a power supply ranging from 5 volts to about 50 volts, which is very much needed for the laboratory experiments. So that was a good use of these adapters, which are otherwise lying, unwanted and unused for. Similarly, you see, I have a scooter which is 20 years old. I was thinking what to do. People said you will get 2005 rupees out of them. So I thought, I can donate it to either ITI or the diploma colleges where the automobile courses are there. So I have talked to the person in directorate. So they have told that yes, they'll talk to ITI where this scooter can be given, so they can, use it by doing experiments and all that. So that is how I think we can exercise this type of economy of the used items for reusing them.
Sure, sir. Thank you. Thank you for sharing your ideas. Yes, there are many ideas, many similar ideas that could be used to
Another
elongate.
thing is in Delhi College of Engineering, we had a huge, chunk of these waste items which we used to call as kabar. Then we conducted one model making competition within the students of electrical engineering, and they were given access to all those waste items and given a time of 3 hours to construct something usable. And believe me, they made 10 to 12 models there, different people, out of that scrap which was there. So it taught them how the used items, the kabar, etc., can be really used in a useful manner. So that was a good exercise for the students. Yeah.
Thank you, sir. Thank you so much. That was really helpful, and I think it's a great idea.
Thank you. Thank you, Tandon, sir. Any more questions? There is Selva Priya. Can you hear Selva Priya?
Yes, sir.
Yeah, you
Thanks
can.
for
You
having
can.
this class, sir. It is more useful to me. I learned more today. Thank you.
Thank you
Thank
so
you.
much.
It's an honor, Selvar.
So ma'am, can I have one question asked from my side? Ma'am, in the
Sure,
first
sir.
slide, first two slides, I think, Brazil was ahead of India. Was that consumption, Brazil was consuming more?
Yes, sir. The consumption power is increasing more.
The equally emissions were this thing. I thought Brazil was, the population here is much more, so I thought the industry.
You're talking about which slide? You're talking about the development slide?
Yeah, the development slide with a graph where Brazil was just behind
So the
US.
consumption per capita. So problem is India's per capita, anything divided by 1.38 is lesser. So the overall, we're not talking, we are talking about the per capita consumption. So that's why maybe Brazil is high.
Okay, right.
The overall consumption in India may be higher.
Yes, that's true. So we have any more questions? So since we are out of time also, I think we can end here. So I would like to give the vote of thanks. Thank you so much, Miss Shalini Goyal Bala. Basically, it was a very enriching and enlightening lecture and this presentation. I feel the circular economy may not be confined not only to academia and industry, but it should be a part of our life so that we help in improving our planet and help in mitigating our climate change as well. So I would like to thank the other panelists, Dr. Datta sir, our chairman, Professor Anil Sarasbude, and all the participants who have joined us, and some who have joined in on YouTube as well. So in case of any, I'm sure we would not be able to do justice in just half an hour or 1.5 hours for this vast subject, but what we intend to do is basically to generate interest in the subject and to spread awareness. So thank you so much again, and in case of any queries, you can reach out to Miss Halini on that. I think the ID is md@ic-ce.com. And for the internship, that would be a good opportunity for all the students. Please make use of it. So we'll be hosting a lot of more webinars like this. Thank you so much. Today we'll close with this. Thank you so much.
Thank you so much, sir. Thank you, Dr. Amit Datta, Chairman, sir, John, sir, yourself, and your team and the STPC cell for calling me here today and delivering this lecture. Thank you. And I look forward to associating with you.
We will surely do that. Thank you so much, sir. Thanks.
Thank you. Thank you.